Hi, today we're going to prove triangles congruent using side, 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 angle, and angle, side. And then we're going to write that congruency statement for them. Okay, so we have two triangles up here. Now, each little tick mark says that one side is the same as another. They're congruent to each other. When we have 1, 1, 2, 2, 3, 3, we can then say that we can officially say that this is the same exact triangle. It just may be two, one might be rotated a little bit. But because they all share three sides, we say they're congruent by side, side, side. We also want to match up each angle and side when we label these triangles in our congruency statement. So we'll say triangle ABC is congruent to triangle. Now here's where things get a little weird. Angle A is between side 1 and 2. Between side 1 and 2, we have D. B is between 2 and 3. So between 2 and 3, we have E. And then C is between 1 and 3. 1 and 3 gives us F. So we'll say triangle ABC is congruent to triangle DEF. And A matches with D, B with E, C with F. So we want to keep them in order to match each exact angle. Underneath it, we have two triangles. We have one tick mark, one angle, and two tick marks. So with the sides, we put a little angle. We put the little tick mark. On the angle, we do a little arch in that spot. So these match up by angle, by side, angle, side. And to write that congruency statement, let's start with the first one. Triangle ABC is congruent to triangle. Now A matches up with 1 and mystery side. 1 and mystery side, so that'll be D. B is between 1 and 2, and it's got our angle between 1 and 2, and it's got our angle, it's going to be E. And C is 2 and mystery side, so you get F. So we have triangle ABC is congruent to triangle DEF. We want to match up those sides by side, angle, side. Next, we have one angle, one side, two angles, and we can say that these are congruent by angle, side, angle. So again, these are the exact same triangles, they're just shifted in a different position. Now for that congruency statement, triangle ABC is congruent to triangle. What matches up with A? Well, that's angle, the one arch. One arch is going to be D. B is two arch is E, and C is no arch, we got nothing there, DEF. Lastly, we have one arch, mystery side, I guess mystery side go either way, two angle, side. Okay, this one gets a little more difficult to see, but we have a statement called angle, side. Angle, side. So every time we do this, we always want to try and go in order within our problem. We're like moving along in a circular manner and like an arched manner. Let's match everything up. We're going to say triangle ABC is congruent to, so one arch, triangle D, two arches, 2, E, and nothing is F. So when we do these statements, we're saying that these are 100% identical triangles. They just might be shifted, flipped, mirrored, something of that sort. And we can use these special rules as we go around in a circle to say side, angle, side, angle, or angle, side. Now, just be aware that there is no angle, side. Angle, side is not something we do in geometry. Now, these are all of our triangles that are kind of broken up. What about if we've got wacky looking pictures here? Well, can we use this to kind of figure out one of our four? Not that one. Okay, so here we have a side that's shared, we have an angle that's shared, and that's it. We only have two things. We really need three. Now, whenever you have two triangles and they happen to share a side, I've got this. Because if I were to take both these triangles and kind of split them off, they both share this middle line here. So now we have something that says angle, I'm sorry, side, angle, side, side, angle, side. And we have that. So let's say we've got side, angle, side, and our congruency statement. Let's go triangle JKM is congruent to, so J is no angle, no angle. Triangle L, JK has one angle. Down here we have one angle, M, and M, JKM goes to, geez, L and K. There's your statement. Now we got a funky looking one down here. So here we have some extra little features. We have these little arrows, these little speed marks here. Those arrows mean we have parallel lines. And we also know that these little tick marks say we have congruent lines. They're the same. So, okay, so much going on here. When you have two lines that cross each other, they create vertical angles, meaning those angles are the same. So here we have an angle that's, or sides that are the same, we have angles that are the same. But also, when you have parallel lines and a transversal that cuts through it, when you have something basically that looks like a Z or an N, something of that sort, we have alternate interior angles that are the same. So now, does side angle angle, side angle angle, or rather angle angle side work? Yeah, so let's use that. So this is good by angle angle side. We can say triangle JKL, JKL is congruent to triangle. So J is 2, that's M. K is by itself, that's N. And L is in the middle. We still have that. Same thing. And that's using proving triangles congruent with side, 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 angle, side, angle, and angle, angle, side, not angle, side, side. Just doesn't work.